Okay. Configuration. By the time we're done, you'll be able to be more familiar with the IPL process. IPL stands for Initial Program Load. It's been a word that has been used for this operating system for decades. I think this terminology, Initial Program Load, was actually used before a PC bootstrap word was used. And I will describe that, and I'll describe the IPL device and what's called the LOADPARM device. We'll talk again about the support element in HMC. We briefly discussed that when we talked about the hardware. We'll talk about the system parameters / definitions. And we'll talk about the IPL and LOADPARM device using MVS commands. Well, actually, I said describe. What I meant to say was determine the IPL and LOADPARM device using MVS commands. We should be able to determine the LOADPARM member read at IPL time. We should be able to determine parameter libraries read at IPL time. And by the end, we should be able to determine parameter library members read at IPL time. So system initialization. To bring the system up, usually the operator supplies parameters instructing the system to load. So very high level. And there actually is bootstrap code on what we call the IPL volume. So it's a disk volume. And that's loaded into storage at address 0 and control passed to it. You might remember when we went over the operating system overview, and I was talking about dump reading 1, and I talked about this address 0 being something called the prefix save area. And that prefix save area is assigned to a processor. And it was at hex offset 10 that there's something in there called a channel command word. A processor gets involved, goes out to the disk device to read the bootstrap, very much like other operating systems. Linux has a boot record, Windows has a boot record, it's on disk. And you got to go out there and get that boot record. So what happens is the bootstrap reads what we refer to as the IPL text and a program called IEASYSLV that is on that disk that you went after. And so there's IPL text, which is and program IEASYSLV, which is given control, and the complex task of loading the system starts. So this here is actually it's basically a Linux application. And this Linux application, just a GUI, it can run on the support element. The support element is the laptop inside the mainframe. So you can walk up that laptop, bring this screen up to actually begin an IPL. Now, another thing that you have available to you is something called the Hardware Management Console, which is a standalone PC outside of the mainframe that can talk to the support element, either one support element or many support elements. So this same application can be used remote of the system or go up to the system at the support element. So in this case, what a person might do, this system right here, ZOS2, it's red, and we got it. You can actually customize all these colors. You could take that and you could place it on load and click enter or drop it there, and it would begin to bring up the ZOS2. So what happens is when you do that, it actually comes back and says, what's the load address? And in this case, the load address 1000 is a disk device that the system knows about, and it says go to that disk device, and on that disk device you should find the bootstrap program. Also, we give it a load parameter. What this load parameter is, the first 4 characters also is a disk device. The system knows about the disk device, and we're telling the system, go to disk device 0C-E3. And when you go there, you should actually find a data set that begins with sys1.IPLPARM. See, we've got to tell the system where to go because there is no master catalog. You got to tell it specifically where it is. So I need 2 pieces of information. I need the bootstrap. Also, I need a load parameter. So the first 4 is the disk device, and I'll describe this W1 later. And when I mentioned it's looking for sys1.IPLPARM, that's mostly truthful, but it's not the whole story. And I'll explain that in a minute. Oh, this is me pointing to the boot. Right here is the support element. So you can actually do it from there. And there's 2 support elements in every frame. Or you could use the external HMC, which can talk to all support elements to get this done. So here, device 1000, it would have bootstrap at cylinder 0, and then the IPL text immediately following the bootstrap. How do you get that on the disk device? Well, there's a very simple utility that normally the disk administrators or system programmers know about, and it's very simple. And you run this thing, and it'll actually write that bootstrap and that IPL text right on the front of a volume. So you can determine, you can have many volumes with the bootstrap on it, IPL text, if you choose to. Or you could just have one. Most people will have multiple. So you IPL at that device, and it would have the bootstrap and the IPL text, but then we give it a load parm, 0CE3. So it finds that disk device, and it goes to that disk device, and how it really works. On that disk device, you're at the VTOC now. And on VTOC, I'm looking for a data set in the VTOC. And the way the system really works, it looks for SYS0.IPLPARM. If it can't find it, it looks for SYS1.IPLPARM. If it can't find SYS1.IPLPARM, it looks for SYS2.IPLPARM, all the way up to SYS9.IPLPARM. So it looks for SYS1, SYS0, all the way up through SYS9.IPLPARM. But it's hard-coded. It's looking for that IPLPARM is that low-level qualifier. That ends up being a partition data set. That partition data set has members inside of it that begin with load, and then it will end with a suffix. Notice here in the load parm, I said, here's a device address, and I said W1. Well, what we're doing is we're saying, go to the IPLPARM data set, find load W1. That's how it's working. This is an example of what's in sys1.IPLPARM load W1. There are things in here. Notice this entry here, syscat. This is the master catalog. And this entry here says, you have a volume label out there that's VP-MVSB. That should be the volume label. And it turns out that it's on device 113C. That's the hardware device address. And the master catalog name is masterv.catalog. You should find your master catalog there. Also, it has this thing called SYSPARM in here. And I want you to notice this PARMLIB entry in here. What the PARMLIB entry is the parameter libraries. And it says, here's your parameter libraries for finding more information that you need to IPL. And it is what's considered a concatenation. Search in here first, and this is a partition data set with members. If you can't find something in there, then search this parameter library to find it. If you cannot find it there, then search here. Finally, search here. Now, our environment is a little bit more complex than most, and that we have multiple PARMLIBs, and notice here, there's a SYSPARM entry. A lot of people in a lot of shops will just go SYSPARM and it'll say 00. And so they'll just have one SYSPARM member, but this SYSPARM member, what it's really looking for, it's really looking for IEASYS and then a suffix. So it's going to search for IEASYS 00, and it's going to look here. If it can't find it, then it's going to look here. If it can't find it, it'll look here. If it can't find it, it will look here. However, at this point, it's not done. I actually coded more. I said, I also want you to find IEASYSLV. Look in here. If you can't find it there, look here. If you can't find it, continue on. Same thing is true for IEASYSSV and IEASYSVN. You might ask yourself, well, why don't you just put it all in one number? That way you don't have to do that. Well, we do something very sophisticated here to serve many hundreds and thousands of operating systems, and it's a scheme we have to help support the whole environment. So we actually got to search through all of these to put together a single IEASYS member. So it actually reads multiple of them, and by the time it's done, it's got all these parameters that it needs to continue on. So let's talk about this module, IEA-IPL00. Well, what that module does, it prepares the system by clearing central storage frames to zeros. Then it defines the storage areas for the master scheduler. I mentioned earlier that and actually I think it was on, I believe it was on Monday, we talked about the operating system overview. No, that was actually Tuesday. And I mentioned the master scheduler is address space ID 1 is the first thing that comes up. Now, there actually is a data set on the IPL volume. The IPL volume, the system knows about the IPL volume because you gave it. And after IEA-IPL00 does its job, then it goes to the IPL volume and it's looking for a data set called SYS1.nucleus. Inside of SYS1.nucleus is another group of IEA-IPL modules. You would find IEA-IPL01, IPA, there's a whole bunch of them. They're all involved with getting the system prepared to actually begin to do work. So I mentioned it actually is configuring the storage area. So what it's configuring is 0 to 16 exabytes, and it's mapping things out where the private area is. The private is your virtual, where you can put your pages from your virtual storage address space. And then there's common areas, common to all address spaces. And it's actually determining sizes, and then it's going to begin to load the common area with operating system type of information. This common to all address spaces. You actually saw this earlier. This is the same diagram, but just remember, this is frames of 4K. Now, one thing that I'll mention, even the operating system can, in some cases, it can have some of the operating system pages that the system can determine, you're not using that right now, so I'm going to move it to a slot. Remember, a slot is on disk. There are some system pages that you can mark to say, never page that out. I always want it to be resident in a frame. And then there's some that you can say, I want you to be able to page that out if you need to. And then there's some that the system can determine every once in a while, I'm going to modify it to never page it out, or I could modify it and say, yeah, it looks like we might be able to page it out. That's actually this right here, what's called the PLPA, page link pack area, means system modules can be in there that could be paged out. The fixed link pack area, and you can determine which modules are fixed, and fixed LPA means when I put something in there, never page it out. It stays in a frame. The modified link pack area, the system might determine at certain times, yeah, it's pageable or it's not. So this is in the common area, common to all address spaces. So we actually loaded the system and it cleared storage and got everything ready. The master scheduler began to execute. The master scheduler brought up more operating system address spaces, and the system is up. So I want to talk about these system definitions now. ZOS is highly configurable to best serve a customer's workload. There's many system definitions, also known as system parameters, that are read during the ZOS initialization. Many of the parameters can be changed dynamically. So even though you read these at IPL time to control the environment, do you have to re-IPL to change the behavior? No, you don't. The vast majority of them, you can issue an operator command to dynamically change the value. There are many, many default values. Sometimes if you go looking at all the system parameters, you go, oh my goodness, does the system programmer code all those? Well, the answer many times is no. There are many defaults, or you take a sample and you use it. However, a more matured system programmers will actually look at those parameters and go, oh, in our situation, it would be best if we modify that because I understand our workload, and this parameter, by making adjustment, is best for our situation. So more matured systems will change the defaults as their workloads change or what's best for them. And whenever you change system parameters, it's always important to develop a backup plan in case you change a system parameter, you go to IPL, you made a mistake, and then what was I doing previously? You should always have a backup. Now, it turns out that you can almost think of these parameters, it's almost like a parameter tree, and I'm going to begin to look at some of it. However, you can actually go through and actually begin to understand the parameter tree and how things are laid out. However, if you're a little bit confused about what the system really read during IPL time, you could go to the top of the system log if it hasn't wrapped already, or if you do a brand new IPL, and we'll be doing this on Friday, by the way, we'll IPL the system. And at the top of the system log, when the system log initializes, the first message that comes out has a message ID of IEE042I, system log. The system log data set was initialized. And immediately after that, there's a lot of messages that come out. Like, look at this SYS1 IPLPARM on device 0CE3 selected for the IPL parameters. It says load ID W1 selected. And then down here, I want you to observe that the IEA008I message ID, system parms follow. This is a very old operating system. This is a screenshot from a very old one. It says, I know you want me to read IEASYS00. Then the system's expected to read IEASYSLV, then SV, then VN. But then, this is what I'm trying to get across. There's a whole series of IEE252I messages in the log, and it tells you exactly what member, partition data set member, was read from which partition data set name. So down here, IEE252I member IEASYSLV was found in LVL0 PARMLIB. And there's many. There's not just 4 of them, but I will tell you that inside of the IEASYS members, there's values pointing to other members. Those other members get read as well. All the members that are read are prefixed by a message ID of IEE252I. So you can actually go out to the system log and find them all. And what I've done many times, I write a REX routine that just looks at the log and it'll go through it and say, here's exactly what was read. So this IEE252I, it actually is, as I pointed out, it gives you the member name that was found in that parameter data set name. These are partition data sets. And of course, this comes straight out of the Messages and Codes book. What's the source? Well, it's the master scheduler. So IEE is the master scheduler. And it's reading these parameters to really shape the behavior of the system, loading things like the LPA, link pack area, with system modules, and the common area with system modules. You can actually do an operator command, d-IPLINFO. It will tell you when the system was IPL, what the level is. It'll say it used load W1. It'll tell you which IPLPARM it found it on. There's the disk device. Here's the IEASYS members that were read. And here's the IPL device. Now, I want to know the PARMLIB concatenation. Well, d-PARMLIB. There it is, and the volumes that they're on. So you could go inside of SYS1 IPLPARM, look at load W1 to get these PARMLIBs, or just issue d-PARMLIB. There's a question?
You know what the flags are?
Good question. So in the room, the question was, what are these flags? You know what? This is a great question because I don't know the answer to that. And I can tell you exactly how we would find out. So let's go do that right now as a great exercise. I'm going to go here. And, oh, I need to share my screen. Thank you. That's a great question. And I'm kind of curious what that flag is myself now. You can see my screen right now, correct? Okay. So I do a d-PARMLIB, because the one thing I did not put on that screen was this, IEE251I, and there's the flag. So I don't know what that is. How do I find out? Well, edit copy. Let's go to the internet. Not the one I'll use that one. Now, you could do a look at, but chances are, if you do this, it'll probably take you right to look at. Oh, it didn't. But let's see, that too many people described it. I'm going to go to look at and do it. Because I want to get straight out of the manual. All right, here we go. And let me paste that in. It was up there and I probably missed it. And I'm on a version 1 release 13 system. Go. And those flags should be in there. So there's the flags. F. So let's look down here and see what it says. Describes how the PARMLIBs were specified. So this was specified in the LOADxx. However, we did also specify SYS1 PARMLIB, but I will let you know it is the default PARMLIB, which probably is implying that we didn't have to specify it. but we did. So it's the default one, but that doesn't mean, default doesn't mean it's the first one read. The first one read was at the top of the concatenation. Yeah, so thank you for the question. That was a good one. I didn't realize what those S and Ds were either. D for default, S means it was specified in the load parm. Thank you. Okay, so let's go back to I'll stop screen sharing here. Excellent question. Now, if we go look at SYS1 IPLPARM load W1, you could actually do a 3.4 and look at this. And this is all that it would look like, just like what I had in the screen. That's it. It's text. The system reads that text and knows how to react. Here I'm actually doing a DSpace IPLINFO and a DSpace PARMLIB. We've talked about that multiple times, so I'm going to move on. Now, one of the many parameter libraries in the parameter library, this is kind of unusual. In the parameter library, not in a JCL procedure library, but in the parameter library, one of the many things that gets specified is in the IEASYS member, it actually says, give me the master JCL information. And it's like pseudo JCL. So this is in the parameter library, and this is actually the master scheduler JCL. Remember I mentioned to you that when you start JES, the purpose of JES is to read JCL. That's the purpose of JES. However, when you start JES, JES itself is JCL. So who can read that? The master scheduler. And right here, this DD name, STCINRDR, started task can actually input into the master reader or the master scheduler to start JCL. This one here, TSOINRDR, that's an internal reader for TSO to do submit. And this is a statement to make it happen, this DD statement. And this program here, IEEMB860, it's got that hard-coded inside of it. When they did that, many years ago, Hollerith cards could go away. Now you could have syntax inside of electronic form internally read and submitted to the internal reader. But anyway, this is in the PARMLIB data set. It's almost like pseudo JCL for the master schedule. And the reason you need it is because it says if I do a start of JES2, I need to know where to look to find it. So these DD statements here and here, notice IEF jobs, in this IEF PDSI, well, the master scheduler, the program IEEMB860, knows to search through here for any started JCL proc procedure, JCL procedure. Now, one thing that I've done, and I'm going to be using this later, that's the reason I have this slide, there is a trick you can do, and there's a utility called ISRDDN, and this utility in the ISPF environment, it will show you all your allocated data sets. But what I like to do, this is a TSO allocate command, and it's a continuation here. I create a file called $parmlib, and then I put my PARMLIB data sets. By doing that, I can search through all 4 PARMLIBs like it was one big PARMLIB data set. So I do this so that I don't have to, where is IEASYSLV? Where is LV? I can actually do this and it'll find the first occurrence. I do that also for the JCL procedures, and I do it for the master scheduler STC jobs. And I do it for a couple other things. But anyway, all I did here, this is actually considered a C list. It's a very simple command list just to execute. And it's TSO commands. Allocate, allocate, allocate. Then I do this ISPF command called ISRDDN that shows me all of my allocations. Let me actually screen share now and show you that. And I'll show you why I do things like that. So I'm on the system, and what I could do, I could go to equal 3.4 and say, show me vendor.parmlib. And then I could view it, and here's a member, IEASYSLV. But if I look at it, all it says is dump equal ASD. I will tell you that is not enough to bring, that is not enough to bring the system up. It's not enough. In fact, there are certain things you must code inside of there. The accepts a lot of defaults. Now, let's go look at another data set, svtsc.parmlib. And if I were to view that, look for IEASYS members, there's one in here called IEASYSLV. And if I look at that, I see more things in here that are very important that you must have, like my slots. What are my page data sets? Well, my page data sets are page, and oh, by the way, that right there is a system symbolic, and the system understands to substitute the system name. Why do we do that? It's very clever. We can use the same syntax for starting multiple ZOSs to participate in a parallel sysplex. But this is your slots. Other things that happen, right here, see this OMBS equal? Well, what that's looking for, it says you should find a member called BPXPRMOM. And inside of there, you're going to find information needed for the Unix System Services environment, like the optional values and the mount points. But do we read just one? No, we read many. Once again, could we put it all in one? Yes. But we don't, because we have a highly dynamic environment that I won't begin to try to explain here. There's other members that are read, like I mentioned link pack area. Modules that are going to be loaded in the link pack area. It goes out there and it finds a member, LPA, LST, 00, then LPA, LST, 70. There's a lot of these. But notice, I would have to start looking through all 4 PARMLIBs to find these things. That's why I created a little C list. I just call it SYSLIB. And what it does, it actually, because I allocated this, here's an action column, and I can do view, but when I view it, that's the file name or DD name, and it looks through all 4 of these data sets. So when I hit enter, it's like a giant partition data set, and notice we have a library column where it found it. So now if I look for the IEASYS members, I happen to know the first one I'm reading is 00, and that's what 00 has in it. Then I'm looking for LV. This is what LV has in it. Lots of stuff. Then I'm looking for SV, and that's what it has in it. Now, you may have observed that this page information was in the previous member. The way it works, the last member read overrides any duplicate parameter. Then the last one we're reading is IEASYSVN. So that's how it's working. But if you're confused by that, you can go to the system log and find them. Let me go to the system log right now and see how it looks. Let me see if we got the, at the top, if we've got the, good, we do. So if I find IEE 252I, there's the first occurrence. I'm going to go over to the right here. Now I'm going to do some repeat finds. There's the next one, the next one, the next one. Here's some more things being read. I can keep going. Well, it also read GRS CNF00 found here. It read this member found in here. It read this member found here. So you get the idea. There's a lot of members read. You get the idea here. All that is read at IPL time, shaping the behavior of the environment. And ours is probably more complex than most. Let's go back to the presentation. This is what I just did. So I demonstrated this, and this is in your presentation in case you want to try it yourself later and look around. And this is a bit of a repeat because I'm actually showing you what I did, and this is good that it's in here in case you want to try it yourself later. Once again, this is what I did. And there's a question? Yeah. So the question was, the concatenation that I did, is this for my own use or for the system? It's a little bit tricky to answer that, so I'm going to try to answer that. I did that for my own use, that concatenation. However, that is indeed the system concatenation also. But the reason I did that for my own use so that I didn't have to go to 3.4, look at this library, go out, go to this library. I did that so I can search through all 4 of those concatenated libraries, so I did that myself. It was just a little trick, just a little system programming trick. So hopefully it answers it. Okay, so I'm going to step through these screens that we already did. And this gives you an opportunity to try that later if you want. Okay, let me talk about system libraries. So in the master catalog has a number of data sets that begin with SYS1. In this, the SYS1 data sets must exist in the master catalog. So you don't have the possibility of putting SYS1 ever as an alias. That can't exist. SYS1 alias cannot exist because SYS1 data sets are in the master catalog. So there's a number, when you get the shrink wrap operating system, the shrink wrap operating system is going to come with a number of SYS1 data sets. So there's one data set called SYS1 link live. This is your primary system software library. Is it the only one? No. You can actually have others when you install products or even install operating system things, but it's a primary one. You'll almost always have a SYS1 LPA live. System modules are in there. Can you have other LPA libraries? Sure, you can. Now, let me go back up to this one, the SYS1 link live. This is the primary one for searching for system modules. However, in the system parameters, you can actually determine the linked list. The linked list is like the path, and you can put a whole concatenation of partition data sets in there that have executable modules in them, and the system will automatically search that linked list. When you say execute program or someone calls the program, it can look through that linked list. Now, these are common modules to all things in the LPA. Of course, SYS1 Nucleus, I talked about that. It has more than the IPL modules. It's got a few other things. There's always a SYS1 proc live, which are system JCL procedures. But then, is it the only procedure library? No. You can have a proc live concatenation to search for system procedures. Then you have a SYS1 PARMLIB for parameters. Is it the only one? No. You can have a PARMLIB concatenation like you saw that what we've done on this system. There is a search order for programs. And there's a very specific search order for programs. So if you request, let's say in JCL, that's the example, you say execute program equal. Well, there actually is a search order for that. And the general rule goes like this. In the JCL, right after the execute program equal, you can actually say //steplib DD, data definition, and point to a partition data set that's got executable modules in it. So what it'll do when you execute program A, it will actually go to this, if there's a steplib in the JCL, it will go there first to find module A, because that might be a private module the system doesn't know about. If there is no steplib or it cannot find it there, right after the job statement, you can put //joblib. It will go to that joblib, DD, look through those partition data sets for module A. If it can't find it, then it goes to the system link pack area, modules that were loaded into common storage, and say, well, is module A in the link pack area? And if no, then it goes to the linked list, which is a concatenated group of partition data sets, and it looks for module A. If it can't find it there, you'll actually get an append which says 806. I can't find that module. Here I'm talking about the link pack area, LPA, and I mentioned this earlier. There's actually LPA, LST, and that suffix right there. That suffix is the different PARMLIB members that are read that actually instruct the system what modules to load into common storage. Oh, this one here, there's a member called IEASYSLV, and by the way, how's the XX determined? That's in the IEASYS. In the IEASYS, there's a value in there that says, here's the IEA fix members you want. So the IEASYS will have that, the XX piece. And so IEA fix says, oh, I've got some modules I want you to put in fixed LPA, which means don't even think about taking those pages and putting them in slots. Keep them in frames. And as I mentioned, there's a pageable LPA also and a modified LPA. So in the case of JES, when you start JES, JES actually has these things like proc 00DD names with a PROCLIBE concatenation. So when you actually are looking for a proc or starting something, it looks through the JES PROCLIBE concatenation to find a JCL procedure, or you can have private JCL procedure libraries. In this case, here's my job, and you could code a JCL statement and just say JCLLib and order equal, and then you can give it partition data sets that have JCL procedures in it. So in this case, when you execute proc equal myproc1, it will search here first to find myproc1. If it cannot find it, it will go to the JES PROCLIBE concatenation to search for it. Also, you might notice this statement here where I said execute proc equal myproc1. That is also syntactically the same thing as just saying execute myproc1. Because on the execute statement, you can say PGM equal, which is an executable program, or you could say execute myproc1, and it knows it's a proc because you didn't put program PGM in front of it. But that's also the same thing as saying execute proc equal myproc. So execute proc equal myproc is identical to execute myproc1. There are many system symbols. Some of them are by default, and what I mean is, let me give you an example. In the JCL, you already saw me use ampersand sysuid. Ampersand sysuid is a system-wide symbol, and if you submit JCL that has ampersand sysuid in it, it knows who you are, your ID, and it will substitute your ID in for ampersand sysuid. Is that the only one? No, there's many more system symbols, and you can set your own system symbols at IPL time. Where can you find information about initialization, all these parameters, the shaping the behavior of the environment? Well, in the ZOS MVS bookshelf, there's an initialization and tuning guide, and there's a ZOS MVS initialization and tuning reference. This is where you read all the information about how you can configure the environment at IPL time. Now, one thing I want to mention, it was very interesting to me many years ago when someone used the term, they said, oh, I'm going to be hacking the kernel, and this is in the Linux environment. And I said, what does hacking the kernel really mean? I didn't know if they were actually going through the live operating system and zapping it. I thought maybe that's what they're doing. No, what they meant by hacking the kernel was that, well, I have to recompile the kernel because some of the parameters that shape the global behavior of the kernel, the way to make it available, you have to recompile the kernel. And I went, oh my goodness, that is incredibly archaic. Because in this system, you don't recompile the whole operating system to change the global behavior. It reads text at IPL time that can be changed. We can modify it on the fly. That's not necessarily the case with Linux. So that some people say, oh, modern operating systems because they're newer. No, more mature operating systems may be more mature and superior. Now also JES, as I mentioned, it also has an initialization and tuning guide, a guide and a reference. As you know, when we start JES, it's a very important subsystem, and it also has many parameters shaping the global behavior of JES. So these are very important books for shaping the global behavior of the environment, and many system programmers become familiar with what's inside of there. Okay, so now you know more about the IPL process. You understand the IPL device, the LOADPARM device. We've talked about the support element and HMC, the role it plays in IPLing. We've described the system parameter definitions. Now you can determine the IPL and LOADPARM device using an MVS command, dspace IPLINFO. Determine the LOADPARM member read at IPL time. Well, you can look for the IEE252I. That's one way of doing it. And also the dspace IPLINFO provides it. Determine parameter libraries read at IPL time, IEE252I, or go through the syntax of the IEASYS member. Determine parameter library members read at IPL time. Same answer. You can look through the syntax of the startup parameters or look at the IEE252I message. Okay, so that is the end of this session.